For this experiment, we made an iodine clock reaction, which is an example of chemical kinetics. For this experiment, we made two different solutions, solution A and a solution B. For A, we put 200 milligrams or 2,000 milligrams of crushed up vitamin C. I got the 500 milligram tablets, so I had to use 4 of them. We had 5% iodine, which I don't know what I did with it. My iodine. Um, and distilled water. For solution B, we used 0.4 grams of cornstarch, 150 milliliters of 3% hydrogen peroxide, and we mixed all that up. Oh, and we used distilled water in that one too. We first made the first solution, and while we let it sit, or while it was filtering out all the extra particles of the vitamin C tablets, we made the second solution. After both solutions were made, we combined the same amount of both and let it sit until the color changed, and it changed to kind of like a really dark blue, almost like a green blue, navy blue color. This is one of them. This is my A. Didn't change colors because it was not turned yet, but this is the final. It's kind of like a dark blue. I don't know why there's a foam at the top of it. I think it's from the hydrogen peroxide. During this experiment, we actually had two chemical reactions happen at the same time. When we combined the two solutions into one, we put the same amount and we had to let it sit. And when we combined them, during the reaction, two forms of iodine was created. In reaction 1, which is the first solution A, the iodine ions react with hydrogen peroxide to produce the iodine element, which is the blue presence of starch. However, because we had the vitamin C tablets in the first one, that couldn't actually happen because the vitamin C quickly reacts and consumes the elemental iodine. So that's why in the first one, like this one, the reason this one didn't change colors was because the vitamin C was causing that reaction to not happen, and it was soaking it all up because we had that whole lot of the vitamin C tablets in there. And then we combined the results of both, combined A and B into one container, and the combined result was, at least part of the time, is that the solution remained colorless with the excess of iodine ions being present. After a short time, I took about around 40 seconds. If I would have heated up the solution, probably would have happened a little bit quicker. But as the reactions kept proceeding, the vitamin C gets used up completely with the two solutions put in it, so the vitamin C got used up. And once it was used up, the solution turned the blue color because it didn't have the vitamin C keeping the reaction from happening. And that is because now the iodine element and the starch are present in the solution, and that's why it made that blue color, where it would have made the blue color in the first solution, but it didn't. And the reason the second solution didn't, like solution B didn't make, is because it didn't have the iodine in it. It had the starch and the hydrogen peroxide, so that's why that didn't change the color. But when we put them both together, the starch and the hydrogen peroxide helped make the color change. But yeah, and this is my final product. It's like a dark blue. I did it the first time. I had to do it twice because I got colorless iodine, which I think that might have caused it to not change colors like it was supposed to. But I quickly figured that that was the problem, so I had to go back to the store and I got the regular iodine, which was the darker color. And then if you put the iodine in the solution, it instantly starts to go to a lighter color, and then eventually it doesn't have the color at all. It's clear. But once I got that color, that's whenever the experiment did what it was supposed to do. So then now we got the dark blue color that I was supposed to get.